Hello, this is 18A42 Distributed System Final Project Presentation. We are Group 8. I'm in, my teammates are Kaidi and Kenny. Our project is P2P carpool system. So in this project, we build up a P2P carpooling Android application. Every user who has a car can be a driver in this app and creates a group with a destination. So other users can choose to join the group in a carpool with others. Now let's talk about how it works in detail. Server-client architecture needs centralized servers to be managers that handle requests from all clients. However, these servers can be point of failure and a bottleneck to scale up. Therefore, instead of using a server-client architecture, we designed a peer-to-peer architecture that doesn't need to manage and maintain any server to handle team-forming processes. Moreover, we believe that carpooling is an interaction that can be decentralized and doesn't need to be interfered by others. P2P network is just like the actual interaction between people. However, we face challenges in node discovery when designing pure P2P network because a new device cannot discover and access the network without knowing any information about the existing network. After digging into state-of-art technology in Android, we found out that network service discovery, namely the NSD, a zero configuration networking implementation on Android, is suitable for our application. NSD enables devices to advertise itself to the local network. Other devices can discover and gather advertisement information. Then join the group. Local network also provides proximity assumption for departure location, since only people nearby are possible to carpool together. Moreover, it also protects that P2P network to grow too large and become out of control since there are limited possible nodes in the same local network. After forming a group, all nodes are communicate with each other. We've implemented reliable multicasting to avoid failures on sending messages to all other nodes. When messages are not sent successfully, the destination can still receive forwarding messages from other nodes. We also enable drivers to set a passenger limit for the group, so that when the number of people in the group exceeds the maximum number, the device will auto stop to advertise itself. In contrary, it will start advertise itself as soon as the number of passengers is below the maximum. Aside from challenges in P2P networking, we mainly have two skill challenges. One is Android development, and the other is Google Map API. We put the concept of distributed system into real use via building an Android mobile application. It's our first time to develop Android, so we found it's kind of hard to learn and develop. There are many different components need to be considered, and the UI design is troublesome too. In addition, debugging networking components on Android devices is annoying since we need to control multiple devices at the same time. However, Android combines well with Google APIs such as Google Play Surveys and a Google Map API. Besides, unlike iOS that we need a developer's account to run app on device, Android can be debugged on devices directly. And here we use mainly two kinds of Google Map API. We use Google Maps Android API version 2 to calculate distance between two locations. And we use Google Places API to autocomplete for place searches. As for our teamwork, we think that is great. Though our team consists of 3 members from different campuses, we managed to finish the project on time. Every week, we have a regular meeting on Skype, and every 2 weeks, we present our progress to TA and ask for further advice. So here, special thanks to you staff. Everyone wants to contribute and is able to finish his parts on time. We have many ways to co-work, and we are quite satisfied with our teamwork in general. So, if we were starting over, we may design that every passenger can create a group, so that even a passenger will be active in our application. Thank you.